Hello everyone, welcome back to Adson Engineering Academy. Today I am going to do for you one lab experiment, that is free swelling index of soil. In this particular experiment, you're going to learn a lot of things because we're dealing with soil that can easily swell. First of all, what is an expansive soil? This is a soil that swells when exposed to water or when exposed to moisture, and when it is dried, it shrinks. So the soil, this kind of soil, you need to study it very well, especially when you go for construction work. You need to do this test, a simple test that I'm going to demonstrate to you, and you can easily perform it. So in this experiment, what we need is, first of all, we need two graduated cylinders. I have them here. And then I've used them differently because I want to identify them easily. And then I'll use this one for water, and then I'll use this one for kerosene. Right? And then I have distilled water, this. Then I have kerosene. Now I have my soil sample. I have my soil samples here, right here with me. And we need a weighing balance. But I've already taken the weight of my soil, so no need for me to have a weighing balance here. Now, according to IS 2720 part 40, it gives us the procedures to perform this particular free swelling index of soil. But according to that, if you read, there is a note that says if you're considering a soil that is highly swelling, having highly swelling potential, like sodium bentonite, you have to take only 5 grams, and that is the experiment I'm going to do for you. So today we're going to perform an experiment on bentonite. So bentonite, we're going to consider from IS code, we're going to take only 5 grams. If you're using BS code recommends that, BS code 1377 recommends, part 9 recommends that you use only 2 grams because you consider 90 milliliter of what? Of the liquid that you're using. So in that case, you consider that procedure. But we're using IS code, so we're following 5 grams of sodium bentonite. Then we are taking 100 milliliter of both the kerosene in one cylinder and the what? And the water in another cylinder. So let me take you through the procedure. The first thing you need to do is to take the weight of your soil sample. I've already taken 5 grams. So I'll pour them in this paper so that I can easily transfer them into my cylinders. So I've poured them. After pouring them, the first thing you have to make sure is that you need to know which cylinder will be used for which one. So I'm going to use this cylinder for water. So I'll put some part of water, like half of it ready, into this cylinder so that when I'm putting my soil, it's having some water already. Yes, I've put half of it. Then I do the same. This is kerosene. And the question is, why do we use kerosene? Kerosene is non-polar. So that means it doesn't cause any swelling. So you have to use kerosene so that it is a standard way for you to measure that it will not swell. It will only swell when you use water. So I've taken this portion. Now I'm going to take my soil sample and pour inside this. Carefully transfer this soil sample inside the cylinder. 5 grams of soil sample. Carefully, you have to transfer this. That's why I'm using the paper. Yes. So I've transferred the 5 grams inside. That for water. You do the same for that of kerosene. You transfer the soil sample there. Carefully into this. Yes. So after transferring it, you should ensure that you fill this up to what? Up to 100 mark. But you have to remove the air. So to remove the air, you have to shake this carefully. You have to shake this so that the entrapped air is removed. So you have to shake both of them carefully. For some few, like 30 seconds to 1 minute, it will be enough. When you shake it, it will remove the entrapped air before you refill it to 100 mark. Yeah. So I'm done with shaking. The one for water, as you can see. Do the same for this one of kerosene. Shake it so that the entrapped air is removed. So you need to know which one is for kerosene. That's why I've used a different one, radiated cylinder, so that I can know them well, right? So this is for water. Make sure you refill it up to 100 mark, but no soil should be left. No soil should be left. So do this carefully so that all the soil gets to the mixed. Okay, fill this up to 100 mark. Tilt it so that the soil sample move down. Okay. Yeah, that is okay. Up to 100 mark. Okay, as you can see. So that is complete. Then we do the same for this. So fill it and make sure you tilt it so that you pour the water, the kerosene, for all the soil to go down. Okay. Free swelling index of bentonite soil. Bentonite is highly swelling. So, but we're yet to observe what will be the result after performing this experiment. So, up to 100 mark. That's it. So, finally, we have come out with our mix. Now, we're going to allow it to settle for 24 hours. After 24 hours, we're going to see and measure the volume. So the volume in kerosene, we're going to note it as VK. Then the volume in water, we're going to note it as VD. Then we apply the calculations. So which is VD minus VK divided by VK times 100. Then we find what is the swelling, the free swelling index. And if you perform this experiment and you find that the free swelling index percent is greater than 40%, that means it is truly for bentonite, because bentonite is highly swelling. And in that case, if you're doing a construction work, it is risky. You need to do other soil stabilization method like use of lime, so that you can stabilize that soil. Otherwise, it is risky or problematic to do a construction in that particular site. So it is a very important test. So let's wait for our result after 24 hours. So remember that you need to follow the IS code to perform this experiment on the notepad, because this particular soil is bentonite. That's why we're taking only 5 grams. But if it's a normal soil, or you go where you don't know the soil, please, you need to take 10 grams of soil, then in 100 milliliter of the liquid that you're going to use. So let's stop here for now. We're going to wait for the result after 24 hours. Now we are looking at what can we observe after 24 hours. From the experiment we did before, that was yesterday, free swelling index of bentonite soil. So you can clearly see that I have two things to observe right here. As you can see, here the soil has swollen up to 48, okay? Up to 48. So we record, that is VD. I'm taking it as 48, okay? Then VK, there is no swelling here. It remains at half of 10. That is 5. It remains, because this is non-polar, so there was no swelling. So what is our calculations? From the formula, which I told you yesterday, which is VD minus VK divided by VK times 100. So you clearly see that this will be our result. So this is our final result from the calculations that we have made. Now, finally, it is giving us up to 860%. That clearly means that it is unsuitable for any constructions, because it is containing a lot of bentonite, and this kind of bentonite that goes up to greater than 600%, research has shown it that it is what? A processed bentonite, okay? And purposely it is only possible in the laboratory like this. So that's why we are able to obtain 860%. But normally, for any test that you will carry out, according to research, you find that if it is less than 20%, then it is what? Having a low swelling potential. If it is in between 20 to 40, then it is what? Medium. But if it is greater than 40%, that is where you find that it is high or very high swelling what? Potential. That means it contains like bentonite. Soil that has bentonite will definitely what? Have high swelling, and it is risky. So you need to do soil stabilizations and other methods so that you can what? Do the construction in a safe place. Otherwise, it is very risky. Thanks so much for watching this video till the end. Don't forget to subscribe to Hudson Engineering Academy for more of this kind of video. Thank you.